All right, we're going to take a look today at a pyramid. Specifically, we're going to look at finding surface area of a pyramid and what goes into that. But we're going to start with the generals of a pyramid. So, what is a pyramid? Most of you will understand that this is a pyramid. Okay, this is the first thing that comes to our mind. We think pyramid. You think the pyramids of Giza. You're always thinking a square-based, pointy top pyramid. A lot of that's really good. Okay, think about that it has a base, it has a pointy top, which we'll define in just a minute. Um, but a pyramid is a little bit more than just a square base. It's a little bit more than just what we see when we think about the pyramids of Giza or in Egypt. A pyramid in general looks like this. First of all, a pyramid is made up of a base with triangular sides meeting at something called an apex. So let's look at this pyramid and let's define it to start. First of all, we have the base, which is on the bottom. Now, I won't always say it's the bottom. In this iteration, it is, but the base is the point that is, or is the side that is a cross from or not touching the point on top. Think about the point on top. Um, it's the top of it, but we could also turn this around and we could have the point on the bottom and the base on top. The base is that piece that's not touching the point. The apex is the other piece there that we talk about. That's the point. We call it the apex. It's the top. That is just the other part of our triangle or our pyramid. Sorry, and those are kind of our two pieces, the top and the bottom. But again, we can always flip this around and think of it from the other side. Now, inside this pyramid as well, we also have something called the height. Okay. And so when we talk about the height of a pyramid, we're talking about the distance between the apex and the middle of the base, or a direct 90-degree line down to the base. For this lesson, we're just going to assume that all pyramids are right pyramids, meaning that the apex is right in the middle of the base, directly above. Okay, it's not slanted or skewed in any way. We're only going to look at right pyramids. Okay, a right pyramid is just talking about the height is from the apex to the middle of the base. Okay, the apex is right above the middle of the base. Now, there is another measurement that we have to think of and that we have to be aware of, and that's this one right here. Now, we're not going to use the height to try to find the surface area of this pyramid, even though we can. We're going to use something called the slant height. And the slant height is the distance from the apex to the middle of the base, but along the side, along that triangle of the pyramid. And this is going to help us find the surface area of the pyramid, knowing what the slant height is. All right, let's look at it a little bit farther. So here's our same pyramid, and we're just going to dive into it a little bit more. This bottom piece right here, in this case, it's that square, is our base area. We can find the base area by any of the formulas that we use, to whatever shape it is. In this case, it's a square, so a square is just going to be side length squared. It might be a rectangle, so then we do length times width. It might be a triangle, and we do base times height divided by 2. Whatever the base area is, we have to use that formula that we have looked at in the past. Now, the bottom is the base area. Like I said, it can be any shape. All right. Now, the second thing are these triangles. These triangles have a name. We call them the lateral area. The lateral area is all the triangles that make up the sides. It's not including the base. It's only the triangles that make up the sides. Think about that you have a pyramid sitting on a desk or a table or the floor or the ground, whatever you want to think of. And what is visible? Well, it's these triangles that meet at the point. The base is not visible. The lateral area is. And so when we want to try to find the surface area of a pyramid, we have to use this formula right here. Surface area is equal to the base area plus the lateral area. Now, the formula for the base area is going to be whatever shape it is. Okay, so whether that is a circle, a triangle, a square, or any sort of polygon, that's going to be our base area, and we have to be able to find that. The lateral area is going to be a collection of all the triangles that make up the sides. Some of the pyramids we look at, all the triangles will be the same. So we find one, multiply by the number of sides. Some of the pyramids we look at are going to have different sized triangles. And we have to find each individual triangle and then add them all together. We have to be aware of which is which. Now, let's go through, I'm going to do one example with you. I'd like to do this example of how do we find the area or the surface area of this pyramid. Now, looking at this pyramid, okay, we're going to notice that we have a square-based pyramid, and it has a dimension or a base length of 11 millimeters. And then you'll see there is a dimension of a slant height, which is 16 millimeters. Now, it's important that we understand that these are two measurements that we need to know before we can find the surface area. What we're going to do is we're going to use this formula right here, okay? The surface area is equal to the base area plus the lateral area. Now, the base area should be fairly straightforward as it is a 2D shape. It's one that we've looked at in the past, so we should be able to find the base area. So specifically, base area is going to be 11 millimeters squared, right? Base times base, or 11 millimeters times 11 millimeters. That part should not be a problem. We should be able to solve for that. So that's going to be the base area. That part should be fairly straightforward. The lateral area can be a little bit trickier if we don't understand where it's coming from. Now, you'll notice that the lateral area in this case, now again, specifically to this case, is made up of 4 similar triangles, which all have a base length of 11 millimeters and a height, in this case it's our slant height, of 16 millimeters. Now, a triangle, base times height divided by 2, so we can do that, base times height divided by 2, and then, because there are 4 similar triangles, we can multiply that by 4, and that gives us our lateral area. Now, when you are trying to solve this kind of question, you can gladly just plug this exactly into your calculator and hope that it works. You can also do just separately and then add them together, whichever one works for you. It's all good. Trying to find something that works is important. But when you do this, and maybe you're trying to solve this along with me, that's awesome. You can always pause the video as well to try to come up with the answer, but you should get an answer of 473 millimeters squared. Now, be careful in that. It's squared units, right? Because we're talking about area, we're talking about how many squares can we put into there. So when you've done this calculation, you should get a total answer of 473 square millimeters.